Hey all, Ian France here, and I'm going to start by reading a poem. A reader quick, keen, and leery did wonder, ponder, and query when results clean and tight fit predictions just right if the data preceded the theory. And this comes from the source below, harking, hypothesizing after results are known. Now, I wanted to make a video around the second part of data science, which is the science portion. There are many voluminous books at this point on the data portion and how to apply methodologies and such there, but I've actually found fairly few resources on the science portion, and especially around how do you communicate your results. And I wanted to talk about some of the things that I have experienced and the way in which I try to address those with the audience. So let's talk about the scientific method from a data perspective. This is the way that I try to approach problems and questions. Defining the problem, doing some preliminary research on what that problem is, hypothesizing, which is your inductive reasoning portion, designing an experiment or writing a query, etc., starting to collect the data, analyzing those results, and now start moving towards deductive reasoning and claims that you can make based off that analysis. Post the methods and the reproducible research that goes along with those deductive reasoning claims that you're making. If it's possible to do that, really strive to do that. And only after you've completed those, then you can publish your conclusions, discuss your results with your peers, etc. And the reason to go through this is that I feel an obligation to communicate honestly and completely what it is that I've done around the hypothesis to make the claims that I'm making. The source that I put, some of the sources I put down below get into this, and the National Geographic, Why Do Many Reasonable People Doubt Science, has a great quote in here from Marcia McNutt, who's the publisher, the publication editor of the journal Science. And she says, quote, "Science is not a body of facts. Science is a method for deciding whether what we choose to believe has a basis in the laws of nature or not." So it's not a body of facts. And when I've presented the findings from some of the data endeavors that I've gone on, I noticed there's some confusion from a spectator perspective. And I wanted to talk about what I think is sometimes happening. One of the things I think the general populace believes is that science can claim things with absolute certainty. It cannot do that. Even if a test comes back absolutely statistically sound again and again and again, every result is temporary. The next test that you run could disprove your hypothesis, could disprove your theory. So these results are always provisional. And this is stated again by an expert in the same article I mentioned, Francis Collins. And he points out the provisional quality of science is another thing a lot of people have trouble with. And this is especially true in the data-driven field where I tend to use stratified samples, and those stratas are elastic. So subsets of larger population samples, they change, they fluctuate. So my results from June won't be my results for October because the elasticity of the strata changes, grows, shrinks, etc. So the results that I give are provisional and they need to be acted upon rather quickly for them to be meaningful, or at least acknowledge that we need to start consistently doing this every month to build a larger sample size, and then we'll look at the results after 6 months and see if the hypothesis and claims hold up more than just on an individual basis. This initial point, though, that people think that I'm saying something with absolute certainty, even with strong statistical evidence, though, it's not true, and I try to state that as often as I can. And this is partially connected to the other area that I've noticed is that there seems to be some belief that science can disprove something. And of course, the former case that I just made actually would lead you to say no, science doesn't disprove anything. No number of positive confirmations of your hypothesis or whatever it is that you're testing can ever disprove anything and can never claim something with absolute certainty. Now, what it can tell you is that this is very, 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 very likely to continue, and you get to then decide for yourself when are you ready to accept that that won't change for some time. Not that it may never change, but that you're open to the idea that I can accept this as a foundation and I'm able to move forward and I can build upon this foundation with confidence that it will remain the same for some time, and thus do other things and build other theories and other results, etc. You get to draw your own conclusion on when science makes a claim, given the very high probability of when you would like to accept that. Now, there are some pitfalls here, and that's why I posted the Clever Hans skeptic dictionary link down below. This was a horse that supposedly could count and understand human language, and scientists were fooled. They observed this, they tried to figure out, oh, this is actually happening. It was total trickery. And if you watch the James Randi documentary that's came out last year, he went through Carlos, his friend and partner. They they intentionally deceived people. They even tricked scientists and showed them you too can be fooled. And so even very controlled laboratory experiments in which he had two plants, two magicians, actively deceiving them consistently and manipulating the experiments, even in a controlled environment. That can happen. So science is not free from fraud. So be careful of when claims do happen that they may be rigged, and that's some of the additional material, microscopes, the gels, the data that people rig in order to get results. The fact that people can buy publications, which offer no peer review, and then claim these as valid ways in which they have been published, all can happen. But the method that I laid out and what Francis Collins restates is that science has a means of self correction. Yes, you can temporarily get away with these things, but the reproducibility, the attempt to prove a hypothesis again, the ordered structure and how people think, not just what they believe, but there's actually a structure on how you think as you move from inductive to deductive reasoning. And this will self-correct in order to get to things that we can say and that are backed through the experiment that we designed and that others are able to additionally prove. So it's a rigorous path. It's a slow path. And the 538 article also makes the point that it's a difficult and hard path to continue down, but that's the way that we actually do science. And so in the ways that in the encounters that I've had, I find just oftentimes fruitful to remind the audience around claims that you make. And I recently finished some analysis of customers that are loaded into a particular instance and environment, which may be up into the thousands, and what is their correlation to call volume. Now, you would expect that if you had 5,000 users on an application, they may drive a higher call volume than, say, 50 users in an application. And I actually found this not to be the case. So I can't prove statistically that the more users that are put into an environment, the more calls the help desk will receive. And that's counterintuitive. And when you present things that are counterintuitive, it's good to make sure that you have honestly and completely gone through these methods as you share and discuss those results. So, overall, I hope you'll find this insightful if you're working in the data science field, and I look forward to any comments or feedback. Thanks a lot. Bye.